Hello students, I am Manoj sir from AP. Today I am going to teach coordinate geometry. It's a very interesting topic, coordinate geometry. So first I will tell the brief history of coordinate geometry. Coordinate geometry was introduced in 1637 by French philosopher and mathematician René Descartes. He described the position of a point on a plane. According to his name, coordinate geometry is also known as Cartesian geometry. Yes? So this is the brief history of coordinate geometry. Now, today I am going to discuss these points. First point is learning objective, that means why we learn this topic. Second point, coordinate plane or Cartesian plane or 2D plane, two-dimensional plane, and quadrants. And third point is order pair and coordinates of a point. So these 3 points I will discuss one by one. So first point is learning objective. That means what is the importance of learning this topic? What is the use of coordinate geometry in our real life? Real life uses of coordinate geometry. The first is urban planning and smart cities. City planners use coordinate geometry to plot roads and public transport routes. Second, design parks and infrastructures, allocate utilities and resources, simulate traffic flows and future city expansions. For one example, designing a central park equidistant from 4 neighborhoods using midpoint and distance formula. It also can help identify optimal routes for utilities like electricity and water pipelines. Is it clear? Now, see here one smart city blueprint on Cartesian plane. Here police station, here hospital, here fire station, here school, this is park, shopping mall, residential area, the road junction. So this is a smart city blueprint on the coordinate plane or Cartesian plane. Now, if we want to know the distance between this police station and hospital without measuring tape, if we want to know the distance, how can you find? Then we need the concept of coordinate geometry. Or if we want to locate the midpoint of residential area and fire station, then we need the concept of coordinate geometry. We need the concept of midpoint formula. Yes? So like this, for many questions answered, we have to learn coordinate geometry. Is it clear? Now, second point, coordinate geometry in construction. See how coordinate geometry helps us for construction. Say accurate alignment of structures, measurement of elevation and gradient, placement of beams, walls and columns, integration of CAD, that is computer aided design systems, with real world coordinates. For example, I can say engineers use slope and section formula to ensure structural integrity and precise positionings ensure safety and stability in buildings, bridges and highways. So how much important this coordinate geometry? I think it is clear to you. Now one more important application, that is mapping and coordinates. Maps are based entirely on coordinate systems. GPS and satellite imagery. GPS and satellite imagery, property boundary surveys, city zoning and land division, geological surveys and environmental planning. So all these are important areas where we can apply coordinate geometry. One example I can say, latitude and longitude are real world examples of coordinate geometry. These coordinates are used in everything from Google Maps to weather forecasting. So wide application of coordinate geometry in our real life situations. Is it clear? Now coordinate plane or Cartesian plane or 2D plane and quadrants. Clear? So I will discuss now this part. So learning objective I have completed. Now I am going to discuss this point. Coordinate plane or Cartesian plane or 2D plane. 2D plane means two-dimensional plane and quadrants. Students, see here on this plane one horizontal line, that is horizontal axis, and we can say this horizontal axis as x-axis. X-axis. Is it clear? So this is x-axis and this vertical axis is y-axis. Is it clear? So this is x-axis and it is y-axis, and these two axes meet at this point, which is known as origin. It is known as origin. Now this coordinate axis divides the whole plane into four parts. The first part, this means this first zone is known as first quadrant, and this second zone is known as second quadrant, this zone is known as third quadrant, and this zone is known as fourth quadrant. That means the whole plane, the coordinate plane, is divided by the coordinate axis into four quadrants: first quadrant, second quadrant, third quadrant and fourth quadrant. And we have to give the name in the anti-clockwise sense, not clockwise. Is it clear? Now with respect to origin, the right side x values are positive and on the left side x values are negative. See here, -1, -2, -3, here +1, +2, +3. Similarly, above x-axis the values of y will be positive. See here, +1, +2, +3, and below x-axis values of y are negative, that is -1, -2, -3. Is it clear? So this is the quadrants and 2D plane. Why it is called 2D plane? Because here we are using two axes, x axis and y axis. Is it clear? Now if I use three axes, say like this, x, y, z, three axes, that is 3D plane. Yes, when only one line, say only x-axis or only y-axis, that is the real number line, that is 1D plane. So 1D plane, 2D plane and 3D plane. I think this part is clear. Now signs in quadrants. Signs in quadrants, that means in the first quadrant, plus plus means x is greater than 0 and y is greater than 0. See here, sign of x plus and sign of y plus. In the second quadrant, minus plus means x is negative and y is positive. So x is negative and y is positive. In the third quadrant, x is less than 0 and y is also less than 0. Both are negative. So minus, minus. Now in the fourth quadrant, x is positive, x greater than 0, but y is less than 0, that is negative. That's why here plus, minus. So this is signs in quadrants. Students, I think this part is clear. Now order pair and coordinates of a point. What is the meaning of order pair? See, in the first bracket, x comma y is written. So this is the order pair. X is known as first element and y is known as second element. Yes, but remember, the order pair x comma y is never equal to the order pair y comma x. Yes, but when two order pairs equal, say x comma y equals to the order pair a comma b, that implies x equals to a and y equals to b. Otherwise they are not equal order pairs. Is it clear? Now what is the use of this order pair? We can use this order pair in coordinate geometry to represent the position of the point. So x comma y, this order pair represents the coordinates of a point on the coordinate plane or on the 2D plane. Is it clear? And the first element x is called the x coordinate of the point, which is also known as abscissa, and the second element y is known as y coordinate of the point, or it is also known as ordinate of the point. Clear? Now representation of a point x comma y on the coordinate plane. How can we represent a point on the coordinate plane? See here, suppose This is x-axis and this is y-axis. Now I am taking point P here, whose coordinates x, y. Is it clear? Or the point P can be here, or the point P can be here also, or point P can be here also. Point P may be here, or point P may be here, point P may be here, point P may be here. So we are considering the different positions of the point P. But what will be the sign of x and y, or what can be the value of x and y in different positions? Say x here greater than 0, y greater than 0, because P point here in the first quadrant. Here P point on y axis, that means here x value will be 0 and y is positive. Here x is less than 0 and y is greater than 0. Here x is less than 0 and y equals to 0. Here x is greater than 0 and y equals to 0. Here x is 0 but y is less than 0 for this point, and here x is greater than 0 but y is less than 0, and here x is less than 0 and y also less than 0. So these are the different position of a point on the coordinate plane. Is it clear? Now, how to determine the position of a point on the coordinate plane? Say I took a point, say P here. How will find the position of this point? First, from origin we have to check, or from y-axis, how much distance I have this point. Say I am guessing here 12 units. Now we'll check from x-axis how much I will, that means 5 units. So 12 units and here 5 units. So 12 comma 5 will be the coordinates of this point. Is it clear? So first we have to know how much away from y-axis, that will give the value of x coordinate value, and then we will know from x-axis how much away, that will give the value of y, that ordinate value. Is it clear? Now, how to determine the position of a point on the coordinate plane, that part I have discussed. Now, coordinates of a point in different positions on the coordinate plane. Just I have discussed to find the coordinates of a particular point. Now we are taking different points on the different positions. So A point is here now. What will be the coordinate of A? What will be the coordinate of A here? From y-axis 3 units and from x-axis 1, 2, 3, 4 units. So coordinates of A will be 3, 4. Yes or no? Now coordinates of B. Tell, what will the coordinates of B? So from y-axis 1, 2, 3. But we will write 3 or minus 3. We will write minus 3 because it is from in respect of origin left side. So that's why we will write minus 3 comma 4. 1, 2, 3, 4. Yes. Now coordinates of C. C is where? Here. On x-axis. So on x-axis means ordinate part will be 0. Now abscissa part, count 1, 2. That means 2, 0 will be the coordinates of this point. Now come to the point D. D point is here. It is on y-axis. So since it is on y-axis, so its abscissa part will be 0. Now y value, since it is under x-axis, below x-axis, so y should be negative. A negative value here 1, 2, 3, that is minus 3. So 0, minus 3 is the coordinates of D point. Is it clear? Now come to the point E. E point where from y-axis how much distance are it? 5. 1, 2, 3, 4, 5. And it is on the right side of origin. So positive value of x, that is 5, comma, what is the value of y? That is from x-axis how much I have? 1, 2, 3, 4. 4 unit I have. And since it is below x-axis, so y will be negative. So that means minus 4. Now come to the point F. F point is here. Again see how much I have from y-axis? 1, 2, 3, 4. 4 unit I have. And since in respect of origin on the left side, so value of x will be negative. That means minus 4, comma, how much distance from x-axis? 1, 2. That means minus 2 because the point is below x-axis. So these are the coordinates of different points. Clear? Now how to plot the coordinates of a point on the Cartesian plane? How to plot the coordinates of a point on the Cartesian plane? To plot a point x, y on the graph paper, we have to proceed like this. What? Now we have to start from origin. Yes, we have to start from origin. Suppose y dash and it is x dash. X-axis or y-axis, they meet at origin. So to plot a point, we have to start from this point, origin. Yes. Now we have to see the value of x. If x is positive, then we will move on the right side in respect of origin. If x is negative, then we will move on the left side. Suppose x is 3, that means we will move 1, 2, 3. Then we will see the value of y. If y is positive, then we will move upward. If y is negative, then we will move downward. So for example, suppose y is 4, then again we will move upward 1 2 3 4, that means here. So 1 2 3 and then 1 2 3 4. So 3 comma 4 is the coordinates of this point. Is it clear? But if x is negative, then we will move on the left side. Is it clear? So step 2, move vertically up for positive and down for negative by the y value, and mark the final location with a dot. So like this, say this is the dot, and this dot represents the coordinates of the point. Is it clear? Now it will be more clear if I take one example. Plot the following points on the graph paper. I have taken 5 points, and I will plot one by one these points. See here on the graph paper, again I am drawing one horizontal line and one vertical line. Horizontal line x dash, which is known as x-axis, and y dash, which is known as y-axis. So first point is 6 comma 4. The first point is 6 comma 4. So first I am marking here, this is 1, this is 2, 3, 4, 5, 6, and here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and here 1, 2, 3, 4, 5, 6, and this is minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, minus 4, minus 5, like this. Is it clear? So first point is 6 comma 4. That means we have to move 6 unit and then 4, 1, 2, 3, 4. That means this point. This is the point. Yes. So this is a point. 6 comma 4. Second point is minus 3 comma 5. Minus 3 comma 5. That means x is minus 3. Then 5, 1, 2, 3, 4, 5. This position. So this is B point. Minus 3 comma 5. Yes, this part is clear. Now part C, that is 4 comma 0. 4 comma 0. 4 means here, and 0, that means stop here. So this is C point. Now 0 comma minus 5. X is 0 means the point should be on y-axis, and minus 5 indicate below x-axis. So 0 comma minus 5 is here. Yes, so this point is 0 comma minus 5, and this is D. Now E, minus 2 comma minus 3. Minus 2 means left side will move minus 2 unit, and then minus 3 means downward 3 unit. That means this point is the minus 2 minus 3. Coordinates of E, minus 2 comma minus 3. So like this we can plot the points. Now example 2, in which quadrant the following points lie? Students, I think now you can say the answer easily. In which quadrant the following points lie? The first point 10 comma 12. To know the position of the point, just we have to see their sign. Plus plus indicates it is in first quadrant. Quadrant 1. Is it clear? So quadrant 1, first point. Now second point, plus minus. So plus minus means fourth quadrant, quadrant number 4. Minus 7 comma minus 8, that means both are negative. Quadrant number 3. Now fourth point is minus 5 comma 9, negative and positive. Negative and positive, that means quadrant 2, quadrant number 2. Is it clear? Now example number 3. Find the least distance of the point minus 6 comma 8 from y-axis. Here least distance means perpendicular distance from y-axis. Suppose this is y-axis and this is x-axis. The point is minus 6 comma 8. So suppose minus 6 comma 8 means second quadrant point. Say this point, minus 6 comma 8. We are finding the distance from y-axis, that means this perpendicular. That means how much this? 6 unit. 6 unit. That means not minus 6, because we are finding the distance. Distance cannot be negative. That's why you have to write 6, not minus 6. Clear? Now example number 4. Find the least distance of the point minus 11 comma 18 from x-axis. That means from x-axis means which value? Ordinate value. From y-axis means the abscissa value. So from x-axis means ordinate value here 18. This is already positive. So option A will be the right answer. I think this part is clear, students. Now come to example number 5. The point 5 comma 0 lies on which quadrant? Students, I think now you can say the answer correctly. 5 comma 0 lies on quadrant 1, quadrant 2, x-axis, y-axis. Since ordinate part is 0, obviously it is not in any quadrant. Y equals to 0 indicate it is on x-axis. Yes? Now example number 6. The point 0 comma minus 9 lies on which quadrant or which axis? Option here, quadrant 1, quadrant 2, x-axis and y-axis. See here, in the coordinate I am getting here x coordinate 0, abscissa 0. What indicates it? x0 or abscissa 0 indicate the point should be on y-axis. Is it clear? So option D is the right answer of this question. Students, I think this part is clear. So now if you have any more queries regarding this chapter, you can contact me through my mail ID manojjj@tigps.in. Thank you, students. Have a nice day, and don't forget to see my next video, because I will bring more interesting sums in that video. Bye, students.